Hey everybody, this is Larry. This is me over Q4 of the weekly contest 440. Maximize subarray after removing one conflicting pair. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. So this contest I was kind of very sad about for this problem. I didn't solve this problem, but there are a couple of reasons. One is that Q3 is kind of silly. Apparently a lot of people just got it because, it is very Googleable. But also apparently this one was a set problem from CSES, which is to say a known problem for a lot of people, especially the top people, which is fine. But also Googleable and ChatGPTable as a result. So a lot of people got this one. It is what it is, actually. Yeah, a good amount of people got this one. I didn't get this one. But I also want to complain a little bit rant about this problem is that this problem actually is, even despite all that stuff, is fine. But it also shows you kind of the Python tax, if you will, of how crappy the Leetcode system is, right? And this is just my experience, and this happens a lot, but, but for this one, it kind of was the difference between me solving and not solving it within contest time, right? And the reason is because I did make a silly mistake for this problem, and it cost, as a result, it was time limit exceeded. But the thing with Leetcode is that with a time limit exceeded, you're never sure really if it's your code unless you knew that it was going to be too slow and you just kind of worried, or Leetcode just being dumb, right? Because there are many instances where Leetcode was being silly and the constraints are a little bit too tight and you're just never sure, right? And for this one, it took me too long to realize that it was not, in this instance, on Leetcode's fault. It was on mine, but I already spent like 30 or maybe like 20 minutes trying to convert it to Java to see if it works and all these things, and accumulated a lot of penalties, but and still didn't get it. So until like about 10 minutes after the contest, after I kind of like calmed down and then kind of did everything. But my original idea was a little bit wrong, but I was able to correct it with my second idea of noticing it. But it would have been right, but I just didn't get to that point, which is a little bit sad, frankly, because I think this is a good enough problem for me to solve, and so it's just a little bit upset. And the reason why I talk about this and I start the video with this is because I want you to have the perspective that, like these are the things that are going through my mind when I'm solving, right? And my explanations will always be entwined with that. Like if you want to just go over a generic thing, just ask ChatGPT, or go to the solution tab or whatever and read one, right? But for me, I think what's different about my videos the difference in my video is that I'm doing it live, and also that it is from my experience and how I try to attack, and and in this particular problem, when I'm wrong, try to figure out how to resolve that, right? And and not only the dream, ideal, happy case, right? But yeah, so it's very frustrating with this one, because I really should have gotten it, and I had the capability to get it, and I had the right answer. I just didn't implement it quite correctly, and it took me about half an hour because I didn't know that was my fault, because Leetcode has been historically very bad with respect to the timing. The constraints are really dumb a lot of times, so that's why, right? Anyway, enough about that now. Let's go over this one. So the first thing I want to go over, for kind of our beginners, or maybe not being beginners, just kind of make sure we're all on the same page, is to solve the version without removing one of them, right? Meaning that we have all these conflicting pairs and we have to kind of take account all of them. Well, then how do we do them? So the way that I think about it is that, okay, so you start with, let's just say that's too far to the left. We have like a lot of numbers, right? Let's just say 8, because whatever. And now you have some constraints of like, okay, 3 and 6, and you could kind of draw it out. I don't know, I'm drawing it out randomly, 4, 6, right? And then now, if I want to solve this without any removing any of these, well, we just go scan left to right? And this is what I like to call contribution. It's just that for each number we figure out what the contribution. Well, what's the contribution with this one? Well, there's one sub, and the way that I would phrase it is, if 1 is the last number in a subarray, how many good subarrays are there, right? And for number 1, there's just 1, right? Because this is the only array, so it's 1. For number 2, there's still 2, because you could pick every number from 2 to 2 and 1, right? Or 1 and 2. For 3, for 3 it's still 3. Yeah, right? Because you could do 1, 2, 3, and so forth. So 4, 4. And remember that this is just for individual numbers, because we can sum it up at the end, right? And for 5, it's still 5. And then 6 is the interesting one, right? What happens at 6? Well, at 6, we can only go up to 4, right? So that means that the contribution is going to be 2, right? Because there's only 6 and 5, 6, right? So this is 2. And 7 is the same thing. It can only go up to 4, so that's 3, and this is 4. And then you just sum it up, and that's it, right? So that's how I would think about this one. And when you kind of write in a sample, and during the contest, I did have a notebook to kind of write something similar out, right? Then you see that, okay, well, when I'm at the 6, for instance, I'm like, okay, actually it doesn't matter that I don't care about the 3, I don't care about the 2, I only care about the 4. So we should be able to use that. You should be able to use that to get it, right? That's it. Like, so here, then my idea was, if there's no removing one thing, then we just kind of go left to right. We keep track of the max left side that we've seen, that we parse. And there's some nuance here, and I'm going a little bit fast. But for example, here, we only look at the numbers to the left of the numbers that we've seen the right side for, right? For example, at the 4, we don't care about the 3 or the 2, because 4 is the left side, right? So basically, when we see the right side of a number, we just keep track of the max of all the left sides of the numbers that we've only seen. So we don't even consider 2 anyway until we hit 7, right? Hopefully this is understandable. Maybe it's a little bit fast, but again, we have a more difficult part coming up. And I think this is probably in Leetcode somewhere. I wouldn't be surprised if it was, but yeah. Okay, so this is where when you have to remove one number, it could be a little bit tricky. There are 2 different ways to do it. I'm gonna go over the way that I did it during the contest and a little bit after, and then I'm gonna go over another solution that is based off interviewee solution, cleaned up by a person named Ace on my Discord, that I thought was easy to understand for me, because I didn't understand that part at first. But yeah, the idea here, my initial idea, and I didn't really come to it immediately, frankly, is dynamic programming, right? So I just thought that initially I can go do the same thing as we said, but keep track of 2 things, right? One is the best with no skipping, right? So we keep track of 2 things. We want to keep track of best without skipping so far, or maybe not best, sorry, total without skipping, right? So total, there's no skipping, and this is exactly the same thing that we had in Brew earlier on top, right? You just kind of sum it all up in an incremental kind of way. And then the other one is just with one skip, right? So almost kind of like DP, tick, no tick, right? So maybe something like that. But this is going to be a previous total where so there are only 2, in theory, there are 2 cases, right? It's the previous total plus whatever the new contribution say, right? Where we skip the current, or where we skip the leftmost number, or we just keep on skipping, right? So we already skipped before, then we just keep on skipping. So this is the previous total skip plus the contribution again, right? It's not new contribution, but basically this, I don't know how to write it, but whatever, the contribution, right? But basically the top here is a new skip. New skip from 0, and this is previous skip, right? And that's the idea. I kind of got it wrong a few times, but apparently you have to keep track of what I thought was two things at least. Keeping in mind that, okay, so I mean, this isn't that interesting, so I'm going to erase. But the idea then is that, let's say we have segments like 2, 4, 2, 5, 3, 6, something like that. Well, if we're here, right, as we said, we only have to keep track of the previous biggest, but then if with one skip, we want to keep track of 2, right? Because if we skip to 3, then 6 would just go to 2 in terms of contribution and counting, right? Because then now you have 6, 5, you have 4, 5, 6, and then 3, 4, 5, 6, but you still ends at 2. So basically you keep track of the 2 left numbers to the left of it. And that's really the idea behind this one. Yeah. So with that, I go, okay, well, what is the dynamic programming way of doing it? Well, going from left to right, we keep track of all the numbers that we skip. So what I mean by that is that, let's say, okay, maybe we write a little bit more, maybe 4, 7 or something, right? So then here, here there's nothing, here there's nothing, 3 there's nothing in terms of skipping, and then the 4 we want to add this 2 in. So then now we go, okay, well, going forward, what happens if we skip the 2, right? And then here the 5, same thing, right? What happens if we, well, it's the same 2, so maybe there's no difference. But yeah, skip the 2, right? And of course, and then you get the answer for that one. And then the 6, we skip the 3, right? And then for 7, we skip the 4. And of course, this is the 3 numbers, right? So here, we also calculate for 5, we skip the 2 and the 3. The 6, actually no, the 5, we only 2, right? Sorry. And then the 6, we skip the 2 and the 3, and then we calculate for 2, 3, and 4. And that's it, really, right? So okay, so let's say you do it this way, right? But the problem is that this set, and if you kind of look at it top down, you want to calculate the number for this index, skip where the number you're skipping is 4, and then 3, and then 2, and then you do the math, right? Okay, so let's say you do it that way. But the problem is that if you do it this way, it'll be n squared, right? Why? Because there could be n number of left things, and so this set would be just keeps getting bigger, right? Like for example, in this case, let me rewrite a worst case, right? Maybe you could have 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, and so then by the time you're at 7, you have to calculate removing with the number you removed was 1, 2, 3, 4, or 5, and then have an answer for each of these, right? And of course, that's going to be n squared because you just have n number of previous elements, maybe even 6. Actually with 6 as well. So there are a lot of them, right? So the key thing to note is that, well, you only have to keep track of the last 2 numbers, right? Because of pigeonhole, right? So basically, because if you skip to 6, then you have the 5. If you skip to 5, then you have to keep track of skipping the 5 going forward, because it could be a more optimal way to skip the 6 or skipping the 5, and then one more for skipping the 5 and the 6 and the pigeonhole. Because all of these is that the reason why is that, okay, keeping 3 numbers is enough is because if, let's say you have a number to the the reason why these numbers are enough is because, well, you have to keep track of skipping the max, because going forward, like let's say 8, we want to see if we skip the 6. If not, then we want to skip the 6 and so forth, right? And you have to keep track of the 5 as just like a previous big number, right? Because if you do skip the 5, you want to be able to compare that with not skipping the 6, right? And then now the tricky thing is this group of numbers. This group of numbers actually, yeah. The thing is that for everything to the right of 7, in this case, everything to the right of 7, it increments by the same amount, right? Because basically, for example, and what do I mean by that? What I mean by that is, for example, let's say we're parsing the next number, which is 8, right? Well, if the previous number is 6, then this only adds, in this case, it adds 2 to the 2 is the contribution. Let me change that number again, actually. It adds 2 to the contribution, right? If the previous number, I got that wrong. Sorry. Let me step back a second. If the previous number we're skipping is 6, then 8 would go to 5, so the sum is going to be 3, right? If the previous number we skip is 5, then we stop at 6, so then the contribution is 2 for the 8, and we keep track of both of those. Or it's before, right? In here, every number is contributed the same way, right? Because every number here is going to be deleted by the same number, which is 6, right? Or it's going to be blocked by the 6. So every number here, you can just take the max of these number, because the ones that are smaller, for example, if this contribution is some number x and this number is some contribution x plus 1, well, we're always going to add some number k to it, and as a result, this number is always going to be bigger, right? So you just want the max of everything in the left, and that should be good. And that's pretty much it, really. And as a result, you only have to keep track of 3 numbers every time for each n, so you can do it that way. And that's really the way that I did it. I don't know that I explained it that well. I think this is a kind of a weird problem, honestly, now that I explained it out loud. But yeah, but we'll go over the code, and oh, this is not my code. That's the... Did I have it here? Nope. I think it's this one. Sorry, friends. Hang on. Yeah. The code is very messy, and there is a cleaner code later, but we'll go over it, right? Maybe we could do some optimization as well. But yeah, so initially we start with, and this is my max case testing, that's why I have it here. But yeah, here we start with XY, and maybe a better name is left, right. Let me rewrite this so that I can kind of, you know, explain it while we can. I guess this isn't necessarily left, right, but yeah. But basically, and here, this is just sorting it in a good way. I did get a wrong answer for this. Just being silly, right? So basically, this is saying that when we reach the right side, we want to put left in the thing, right? And here, previous, we want to say, yeah, the largest 2 numbers, right? Smallest first. And at every time, and this, yeah, and best is going to best value without skipping, and then this best of skip sub x is the best. I say best, maybe that's not the right word, but total, right? Total counts without skipping of the arrays, right? We're going to do a lot of rewriting here. So total count is the total count while skipping the number x, and that's pretty it. And then for each number I, we do a sort on this array that we care about, and we only append 2 numbers, and then we get the best 2 numbers of it, right? Yeah, I mean, maybe I could just win and largest, what's it called, hip q that. But I thought, whatever, let's just keep it this way. Basically, what I'm doing is that we want to keep track of the last 2 numbers that we care about, right? In the same way that we talked about, and yeah, and that's just to get the largest 2. The largest 2 number is the last 2 numbers to the left of the right side, right? That we care about. Okay, and then now we have if statements, which is just really going through it. if there's no previous, that means that there's no boundaries. So we just add that, right? And this is just the number of ways giving the index I, right? Otherwise, if there's one element without skipping, oh, and I gotta change the naming, I forget. Yeah, without skipping, then this is just the biggest number, right? Previous of 0 is the number that we are most familiar with, and yeah. And this is just regular DP, right? Keeping in mind that there can only be one value in total skip if we only have one best value, and that's why. So basically, there are two ways of doing it, or whether we've seen the skip or not before. If it is not in total skip for whatever reason, then we set it as new skip value, which is just the previous best plus I plus 1, right? Also straightforward. Yeah, this is just the number that we would have if we skip the index. And then otherwise, yeah, and this is the same, right? It's just that, yeah, I mean, this is plus equal to, so that's why it's a little bit confusing. It's because then now you take the previous number that we have and then we add, this is the number because it goes all the way to the left from the current index, which is why it's I plus 1. And this is the same except for it takes it from the previous best, that's why. Okay, so then now if we have two values, then now it's I think the way that I wrote it is actually better than the way I initially wrote it, which is that, yeah, again, without skipping, it looks like this. Pretty, you know, because this is the next number, right? The biggest number is the biggest number is the most recent index that we care about. Otherwise, for each of these keys, remember that each key is a number we skip. If the number that we skip is the leftmost, or sorry, rightmost, the recent number, the most recent number that was the closest number to us, right? So previous of 0 is the closest number to us. If that is equal to the current number, then we just add it to the next one, right? So then that's the second closest number to us. Otherwise, we skip it to the previous number, and that's it. Otherwise, if the best number that we want to skip is not in the list, then we create a new one where we skip to the from the previous best to the rightmost. And that's it for this one. The next part is a little bit wonky, but honestly, I mean, it's kind of long, but it's understandable, I think, which is that what we want to do now is we want to remove everything that we're not keeping track of. So it's not the two number. We want to get the max. And we just want to get the max of the rest of the numbers, right? If you remember our visualization, we talked about this is like the rest of the numbers, and we want to. So basically, what I did is that I get the value of the max of the numbers that are not in the last two numbers that we care about. So we get the value, and then we just get the first value that's greater than it. It doesn't really mean anything, but it should be fine, right? Yeah. Because the thing is that if you don't skip so we only keep one of them. This is why I have a first thing. Because if you don't, then there are degenerate cases where multiple numbers are equal to the max number. So then it just keeps on growing and you still cover n squared. In fact, that is the thing that I made a mistake on in my first implementation. And I honestly, it is my fault. I blamed it on Leetcode because, like I said, there's a lot of, on this particular problem, isolated, it is my fault, but in a meta sense of everything that you've experienced or I've experienced in Python and Leetcode and stuff led me to believe otherwise, and so that part is Leetcode's fault if you ask me. But anyway, we don't have to rehash that. But in any case, yeah, that took me about 20 minutes to kind of convert it to Java and then try to debug it in Java and so forth, or maybe even longer, I don't know, you could watch the live part. But yeah, and then I realized after a little bit that, oh no, my code is wrong. But unfortunately, I think at that point I only had like maybe like 8 minutes left, and I couldn't articulate what I wanted exactly, so I kind of got a lot of wrong answers, and I didn't get it until after the contest, after I kind of took a minute backwards and then actually solve it. But yeah, but basically what I wanted to do here is just keep track of all the things, the previous two numbers, and also the highest number that is not the previous two number. So in this case, best skip would always have at most 3 values. Well, I mean, after removal, right? After removal, it would have at most 3 values. I guess here we may have 4 values depending on how it shifts, but yeah. And here we remove as a result. Yeah, and the reason why I kind of have it like this is because otherwise you get what do we call it? I forget what, like iteration something change error or something, because you can't change the iteration while you're going through it, right? I guess you can maybe convert it to a list and then do it, but yeah, in any case, yeah, maybe I should have done it that way. Actually, let me see if that works, because I feel like I always do it this way, but maybe that's, I don't know, maybe that's a little bit error prone, right? Okay, so then now we delete best skip key. Maybe that works. Let's see. Except for that, we named it total skip, so sorry about the inconsistency. P best. I may have deleted it by accident, but let's put it back. Yeah, so basically we just set the previous set best to best because we wanted to P best is equal to total. Yeah, it's the previous total because basically we wanted to do this thing without caring about it. Best skip is not defined. Did I not define it? Oh, total skip. Where's best skip? Oh. Wait. I have a nice side thing apparently. Alright, let's see if that, make sure that works. Well, I guess, yeah, okay. I should write it this way in the future. So it's a little bit cleaner now, right? Because the thing is that you have to convert it to a list, otherwise you have an iteration thing issue. And we could show you, right? Like, yeah. See, yeah. Or dictionary change during size or whatever, yeah. Right? So you do need to convert it to a list. But yeah. So that's pretty much it. It's just to kind of get rid of the other ones. And that's all I needed. And I would have gotten a C and I would have been still a little bit annoyed, but at least happy that I solved it. But yeah. Yeah. So that is one way of doing it. That's my way. And I think, honestly, to me, it feels intuitive. Even if the implementation was a little bit wonky. I did have some issues of greedy on the DP, and we watched the live portion. That's also why I took a bit of time. So I didn't come to this directly. Okay, so what is the cleanest solution, right? So there is a cleanest solution. This is, like I said, from UE and ACE. The idea here is the same idea in some concept. It's just much cleaner. Yeah, like this part, I don't know. It is what it is. I don't know that I mean, yeah, I think mine is also not that bad, but it's whatever. But yeah, but this part, we already talked about, right? Oh yeah. I mean, this part is the same as what we had, so I'm not gonna go over it that deeply, except for that I use a collection, they use an array, which is a little bit different. And then yeah, their idea is that, so for total calculates the number of subarrays, assuming there's no removal, right? So total is the same as what we did with no removal. So the total would be the same as if I didn't change total, right? So then the rest is actually the same idea of just, okay, this thing is the total, it doesn't change, but this thing is the accumulation of, okay, if we remove left sub 0, then the improvement would be this delta, right? Because now you have the two most recent numbers. So if you remove the left one, then it improves by this amount, right? And if you want to visualize this real quick, let me bring it back. Maybe not with this one though. But the idea here is actually, whoops. Much honestly, I don't know that I can come up with this during the contest, which is why I don't want to emphasize it. But once I saw it, I was like, oh yeah, that's smart. But basically, the idea is that okay, let's say you have again, 2, 4, 3, 5, 4, 6 or something, right? And then the idea here is that okay, let's say we keep track of the 2 recent numbers. Then here at 6, we go okay. Well, the last 2 numbers are 4 and 3, right? Or 3 and 4. Well, that means that if we removed 4, what does that mean? If we remove 4, that means that we have 1 more away, because here the 6, the additional, the improvement is just from 6, 5, 4, right? Before, well, actually, I was wrong. Sorry. So if we don't remove it, we have just 6 and the 5, and when we remove it, we add an extra 1. So that is basically 3 and 2. For 3 and 4, so your extra 1 is actually this one. If the previous number, let's just say this is a 2, right? Then now you draw an extra 1, right? So that's how you get it, and you go, okay, well, if we remove the 4, you get a +2, so that's why you store it at the 4. And you kind of just keep on iterating it that way, right? Because here, if you have 7, how did that happen? What's going on? If you have the 7, the last 2 numbers, and 4 and 2, that means that if you remove the 4 now, you get again 2 more improvement, right? Of course, you still get this one, you still get this one, you still get this one, but these would be improvements. So the improvement is just these 2 on top, right? So that's really all this one's saying. And honestly, it's so simple, but I don't know. I don't know. Like it is definitely simple. I don't know if it's easy for me to come up with it, is what I mean to say. Because if I did, I would have, right? But yeah. This is just a really fancy way to kind of keep track of the left 2 things. Maybe I will have to steal it in the future, right? Because basically, yeah, it's just a very clean way of writing it. I don't know. I mean, I don't know if it's clean is short, is what I mean. This is the same as what I have here, I suppose. Yeah. But yeah, even in this case, I would sort and so that this is I don't know. So that this you don't have to do, because max is maybe not. I don't know. I mean, I could have also just did n largest, so it's not a big deal. In any case, yeah. I mean, I during the contest, or during, yeah, actually this was during the contest, I got a little bit confused, and I thought that I have to optimize this part of it, because like I said, I wasn't sure at that time. I did not know that I was actually timing out because of this, or not removing all of them and this duplicated thing. So I thought that I had to make some optimization. I wasted a lot of time. If I had known that it was my fault completely, then I would have maybe gotten it, but I spent a good amount of time debugging it. That's why I end up looking like this, because I think I wrote it a little bit more cleaner. I think the way that I had it was just yeah, and like q n largest of 2 previous or something, right? I think that's the function, maybe, right? Yeah, and then as a result, then I don't need this, and I guess this is fine, but I think initially I even just had this. So this is definitely slower, but I'm curious whether it's that much slower. I mean, it's still fast enough. Let's see how much time it. Yeah, so yeah, it is definitely slower, but still within reason. But I wasn't sure that I was having issues or not. Like I didn't know where my issues were. So yeah, yeah. Yeah, and I think but this is anyway. This part is the contribution to RM, and then you just take the max of just whatever you remove and the contribution, right? So that's actually much prettier. I think the reason why I didn't do it this way is because it just I just didn't think of it honestly. And this one, it is there's no sorting or anything, right? So yeah, so this is actually O of N, so very clean. The way that I did it, there is actually no sorting. I mean, there was some sorting before, but that was for 4 elements, so it's actually pretty straightforward. So yeah, so actually it should be the same. I wonder what the running time is. I mean, I imagine their running time is faster just because of the constants. Oh man, much faster. But yeah, that's all I have for this one. Let me know what you think. I'm gonna make this slightly smaller so you can see it. Okay, whatever. It's still too long. But yeah, thanks for watching, and yeah, you could watch me solve it live during the contest and afterwards. Next. Yeah, a quick interjection. Actually, I think there is a cleaner DP which I'm not going to implement. I did a minor change with changing this to, I did clean it up to use the n largest, but also I did it with the leap heap here. But what the oh, and I don't use the first anymore. And what that changed practically, even though the code is very similar, is that it gives the idea that, and I know the font is a little bit small because I wanted to get everything on the screen. But the thing that now it proves, even though I wrote the same idea, but the DP is actually more straightforward, but a little bit more ugly and really hard to implement, to be frank. And it's going to be similar to what I did anyway. Is that there are for every, if you're able to write out the states, this is actually, I think, the way that I would prefer if you didn't do it this way anyway, right? Which is that you have 3 states at every index. The 3 states are total with no skips, right? And then total with skipping the most recent barrier, and then total with skipping not the most recent barrier. And that's really it. And yeah, and you're watching still, I am going to try to upsolve it by writing it that way. Yeah, right. Yeah, okay, let's give it a try. Okay. So then here, instead of total skip, we have total skip. Yeah, maybe total skip, and then total skip. Naming things is hard. So let's say total skip last and total skip not last. I don't know, right? Right, and so this is basically the same. How did they wait? Oh, they just assumed that was 0. Okay, so I think, yeah, we can actually, there are a lot of if statements here, which is a little bit confusing, or a little bit more difficult, even though in the case analysis it makes sense. But we can actually just write -1 as we could count that as the barrier that is, right? That is as like an imaginary barrier that's our index, and then as a result, we can actually already just remove all this, right? Because now we always have at least 2 elements. Actually, let me make sure that this still works first. That would actually be much cleaner. I mean, this code is already cleaner, even though we didn't. Yeah, so this code is already much cleaner. Yeah, but then now let's convert this to the thing, right? Okay, so we have all this. We want to say, yeah. How do I write this? Right. So total, we just, without skipping. So this is always going to be true, right? Yeah. And then total last is skipping the last barrier. So that is going to be, you go to max of the previous total. So let's just say previous total is equal to total. So previous total plus, so skipping the last barrier would give us I minus previous of 1, right? Yeah. So this is skipping the last barrier. And then total not last is equal to p total plus I minus previous of 0, because we don't skip the last one, right? But they're all more, so these are the base state transitions, but I think there are more, which is why I'm trying to think. It's not easy. Which is, I don't know why I didn't come up with it, I suppose. But yeah. And then now, so the other case is that, so this is if we just skip, right? But then now we also want to say last barrier is equal to -1, say, right? Or last recent barrier is -1, right? So if last barrier is not equal to previous of 0, then what? Then or maybe it is, right? So let's say it's equal to 0, then total skipping the last barrier is I think I made this mistake. It's actually either this or the previous okay, yeah, I think I need a previous total last. Right. Okay. Is equal to either that or previous total last plus same thing, right? But it's just that, you know, we can kind of keep the train going, if you will, from the previous as well, because we don't skip anything new. And that's it, right? Because if there, or else, well, no, there's no else, right? That is just, yeah, that is it, right? So it's either this or this. For the total last, and then total not last, if the last barrier is equal to this, I don't how, what do we, oh wait, well, it's just equal to this or total not last plus I minus previous 0, because if it's not the last one, then it doesn't even matter anyway, right? So that's why these are at least true. And of course you could have factored that out, but that's fine. But if they're different, then what happens, right? So if they're the same, only this thing has a better choice, right? But if they're different, then what? Then total not last if they're different, I mean, I guess this is still true, so maybe not. If they're different, then total not last is also equal to total last plus I minus previous of 1, previous 0, because then now it's no longer last, so we have to, oh, this is previous total last, right? I want to say maybe that's it, but honestly I'm not super confident, so yeah, we'll see. But I think that's the idea. I don't know if my transitions are right. My transitions are not right. But I'm missing some transitions. But this is why I kind of struggled writing it. Like I said, like I think the other code that I wrote, as you saw earlier, conveys the same thing. But this is the way that this is would be maybe more closer an idea. But Oh wait, we have to update last barrier. That's why. Maybe. I don't know if that's why, but we definitely at least have to do that. Oh, well, let's see. Oh, so that's not so bad, but it's just so hard to kind of do, you know? But yeah. That is all I have for this one. Yeah, that's all I have for this one. You could see that we made some changes. So it's not so, it just looks both so easy and also so hard to come up with, as you see. But I did wanted to kind of yeah, show you that there are different ways, and kind of show you the equivalency. And yeah, not bad. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you could watch me solve it live during the contest now, actually. 30 people got it. I don't know if that's good or bad. All right, let's go focus. That, I mean, I learned from scratch, so that was okay. Like, I mean, it wasn't from scratch. Like, I had some pre-written code, but I knew the ideas, so just took a long time to. And then I did a silly mistake on this because I was kind of rushing it a little bit, honestly. But okay. Oh, n array nums 1 to n in order. Conflicting pairs, A, B, conflicting pair. We move exactly one element from conflicting pair. Count the number of non-empty subarray nums which do not contain A or B for any remaining. Okay. So basically you have all these things. So there are 9 key. 9 subarray nums 1 to 4 does not appear together. Okay, conflicting pairs, there are, oh, n is just a number. Okay, fine. How many conflicting pairs are there? 2 times n, huh? What does that mean? That is a very awkward constraint. That means that if the number is 1, you could have 2 pairs. You have 2, we could have 4 pairs. There should be an additional constraint, I think, but whatever. I don't care that much. I guess it could. Doesn't have to be unique, even though they don't mention it. So I guess it could be the same thing multiple times. Which is I don't know, awkward, but okay, fine. Okay, what does conflicting pair do? Conflicting pair segment stuff, right? So you have 1 and 4. Then basically, what does that mean? That means that on the 4 side, on the but you have to pick one, right? So you have to do it very quickly. Okay. And a lot of people got it somehow. Well, I mean, I guess there are such just cheaters, but 1 and 4. What is 1? Well, what does 2 and 3 mean? Having a 2 and a 3 just means that you can't both have a 2 and a 3. Okay, what does it mean when you have 2 and a 3? Okay, you want just 1, 2, and 2 and 5, right? Well, they intentionally don't have anything in the middle, though. I mean, okay, so what does it mean to have 2 and 4, say? Well, 1, 2, 3, 4, 5. Well, sorry, I'm just writing on my notebook. That means that everything to the left of 4 is good, and everything to the right of 2 is good. But it just cannot have so basically if you do the math, it would just be okay, 1 is a good subarray, 2 also good, 3 is also good, 4 you cannot meet with 2, so then you just do, so then now you cut off. That's pretty straightforward, actually. Then you're going from left to right, and then maybe DP on the number that we're blocking, maybe, or whether we block the number once yet. Okay, so what does it mean? How do we have an hour to fix this? I don't know if I can. I don't know why I put my notebook all the way to the right. All right. So that's if you have 2, 4, right? So what does 2, 3 mean? I just say for this, or 1, 4. 1, 4 is fine. You just do a left-right sweep. But how do you optimize? Or do we move to 2, 3? But okay, let's say we don't remove the 2, 3. What does that mean? Same thing. So it's sliding, or not sliding window, just contribution things. Very easy contribution even. Because for all of them, you take the min or the max of all the other pairs that you have so far, right? So for example, if you have 3, yeah, so it's just dp on whether we have skipped one yet. So then now, so for each number, we look at all the other numbers that are to the left, right? Okay, I mean, it's doable. It's not easy, but it's doable. 48 people got it. I don't know. It's so hard to tell whether people are cheating anymore. Like, I'm sure there are a lot of smart people, like Morensky maybe, Uwe, but you know, there are also a lot of people just, I don't know. But I should be able to do it. I think I have the idea. Not an easy idea, but idea nonetheless. All right. Best is equal to 0. Best skip is equal to 0. Okay, for nope, for xy in conflicting pairs, we have, well, we just call it f because I'm lazy to name things. We have f of y append x, say, right? Yeah. I think that's it. Okay, right? So then now we have to count for I in range of n. Okay. Yeah. Well, I guess this is best skipping, right? So best with our skip is just going to be previous is equal to an array maybe, right? Okay, so then if length of previous is equal to 0, then there's really not much we care about, right? Because then now best is so for the ith it's just added by I plus 1, right? And then best, if we skipped already, I mean, this is not really possible, I don't think. Then let's just keep it not possible. That doesn't even make sense. I mean, we could probably write the transition, but it doesn't make sense. Okay, otherwise, if previous is equal to 1, then okay, it's a stack of 2 numbers, say, right? Okay, write it down, stack of 2 numbers, smaller first, larger second. So then we have to always take the larger one. So then best is equal to I minus previous, the bigger number. All right, yeah, I guess it's only plus 1 maybe. I don't know if this is off by 1, but it should be close. Best skip is going to be equal to I plus 1 is equal to, well, it's equal to so basically is I have max of either best plus skipping 1 or best skip plus I minus previous 0 plus 1, right? So either we already skipped it or we don't. Okay, fine, right? And then else, yeah, okay, that sounds fine, I think. Yeah, this may be wrong actually. This, let's see if if we go from, and also this is one index, so I'm messing up here. So okay, let's convert it to 0 index, and then also we have to update previous. I think I would update previous actually before this, yeah, before we do the calculation. So yeah, so for k in f sub I, previous dot append k, right? I mean, yes, I want to write something like sorting, but I just want to get top 2, right? Actually, isn't there like a top 2 function in Python? It's like a heap, yeah, okay, that's right. Previous is equal to heap q dot n largest 2 of previous. What does that return? Oh, so then in that case, actually, the larger is on the first. Well, it doesn't. Luckily, it doesn't change this, but larger first. Okay, right. And then now there are always 2 elements. What if there's only 1 element? Does that work? I actually don't know. Let's actually run it real quick. I guess it doesn't do anything, which is good, which is what I wanted to not do, but just want to make sure. Okay. Okay, else if there's 2 numbers, then what? If we don't skip, it is just this as well. Also, I have to, this is actually the previous best, not the current best, so yeah, and then technically previous skip is equal to best skip. Even though I think this part doesn't, like, it shouldn't change anything, but okay, we might as well just keep it consistent. Okay, so that's not skipping. We have to, if we want to skip, then it's just equal to, okay, same thing actually for the first part. Anyway, I could just written it. No, it's not. It's minus previous of 1 plus 1. Wait, let me check. Okay, so the index here is 1. Is that 0? How many elements is there? Then it is 1 minus 0 is 1. So I don't know that there's a plus 1 here, because that's the last blockage. Okay, fine. Okay. So the previous best plus the big number. Oh, this. Oh no, this is the bigger number. So best skip is going to be the previous best plus this. Okay, that makes sense actually. Otherwise, it's just this because we don't skip. And then yeah, and then here we just either we skip or don't skip. I guess we should always skip, but I don't know. Do we have a mod on this one? Non-empty. We might. Actually, my numbers are off, but I didn't know. I guess it doesn't have the mod. It's just n squared. It's just long. It's just in Python. I don't see it. Okay, fine. Yeah, we can write it here at the end, I guess. But why is it 8, 10? What am I missing? 9. Oh, I didn't remove one number. That's why. Oh no, that's I am doing it. Okay, what am I doing? I best skip. Okay, so 1. Okay. Three, yeah. No skip, there's only 1. And then 4, 2 for, okay, so that's right. So one skip is a little bit weird, but maybe not. This is 3 skip, so we skip that, then we have 3, 2, 1, which is 3, which is right. And then 4. Okay, I see. Because the 4 cuts off at 2, that's why, even though we actually wanted to cut off at 1. How do we choose to, how do we mark the number? Because we don't keep track of the things skipped, that's why. So if we skipped, do we just keep track of the number we skipped? Is that good enough? Is that good enough for all the possibilities? Because the previous skip is the only thing that matters, right? And the previous skip, so this is skipping 1, and this is the previous skip. Yeah, maybe. But you already skipped, I guess, that's why. Okay, fine. Okay. Well, we can always just write this. And then here, we have to do something like, wait, what is this? Previous skip? Okay, so we already skipped minus this thing, which is the bigger number, but we already skipped it, and that's fine, right? So, okay. So then if last skip is, or if this is equal to this, I think that's fine. It's a little bit awkward, but it's fine. So if it is equal to, then we actually just, yeah, then best skip is equal to f max best skip, the previous skip plus I plus 1, else if it's not, then we have to check whether if it's not, then man, I'm slow. If it's not, then you do have to. Is it possible that it's not? No, the first time. Yeah, I get that. Oh, wait. Then this is wrong. I mean, this is wrong anyway. Oh, no, it's not. But oh, no. Okay. Well, this is. I think this is right, but then this is wrong. Okay, I think I need to write this first. So okay. Else best skip is equal to, no, this always has to be right, I think. Let's just try this one real quick. And then if is greater than best, what do you do with tie breaking? If it's the same, then you want to skip the more recent number, I guess. I don't think that's possible either, but yeah, the states are very weird for this one. Okay, fine. But yeah, here then we're gonna let skip is equal to I, and then this thing, right? Okay, I think this state is weird, but press skip. I'm gonna set it to the previous skip. Just keep going. Yeah. Well, no, if last skip is none, then I mean, it should be fine. Right. I know this isn't right, but I want to run it first. Why is this? Oh yeah, because last skip is none. If last skip is none, then we don't really do anything. Oh. Okay. And then here, okay, right, and then if last skip is equal to previous, okay, right, no controversies there, maybe. Okay, so if last skip is equal to then best skip, we get to skip it. I don't think that the max is necessary, but I just want to write it in anyway. We skip it, right, which is fine. And then if and last skip is wrong, it should be previous 0. I don't know, I feel like this is gonna be very well, frankly, but that's fine maybe. Alright, well, is it right? I'm not confident, honestly, but why not? It's correct for the input. The idea is roughly right, but yeah, I mean, I think, oh, I was actually looking for that, but I thought I saw it. That's just annoying. That's just a silly thing, right? Yeah. I hate Leetcode. Okay. I mean, there may be another wrong answer, but that is a stupid one. Okay. 212, so expected 230. So maybe that I'm wrong, or I feel like the idea is right, but my implementation, I don't know about this last skip thing. That's the biggest one that I'm not sure about, frankly. Let's see. So what do we have here? 19. Let's write it out. Kind of. 1, 9, 5, 7, 7, 10, right? And then 1 is going to be 1. Oh, the zeros here, it feels a little sketch, but I guess you're never going to skip. So up to 5, you're 21, right? Up to 6. Did I mess this up? No, not like that anyway. We have half an hour-ish. Why would I skip 5? I think that's why I'm pausing. 6, 1, 9. Why would I skip 5? What's going on here? Am I looking at the right problem? Oh, the 6 is a 7. That's why. Okay, I forget that I 0 indexed it. So okay, so then if I don't skip, it's a 2. If I skip, it's a still 7. Okay. Okay, let's actually also print out last skip. Okay, and then now we skip to 4. 4 and 0. We'll never skip the zeros, but but the 9 will now change, right? So no skipping, it's going to still be 4. Okay. I think this thing is weird, that's why. Okay, so when you get to 9, no skipping. Is that right? That probably feels right. No skipping is 33. Skipping is going to be no skipping minus the 6. So that means that it is going to be 35 or something. So I guess that's probably fine. And then the math here probably is right, but it doesn't change anymore though. How do you get 230? So it skips to 7, 5. Does the thing matter? No, I don't think so. Because it just depends on the current number, right? Oh, and n is 25 for some reason. So if we skip to 4, then everything will be based on the 6. So how can it be wrong? What are we skipping? Okay, so on no skip, so we skipped one. All right, let's actually, we can brute force this a little bit. To see which one we should remove. I actually don't know which one we should remove. But we have 30. No, it's 308 because so 230. We have the answer. So we should remove 710 is what we need to do. So that means that we should remove the 6. But why don't we remove the 6 then? Oh, because here the decision to remove the 6 is local. So I go, okay, so because if we end at 11, say, this may be the ideal solution, but not if we end up here. Okay, so I think I'm just really wrong on this. Okay, I see why I'm wrong. Because all this accumulates, because this then is 2 per whatever, right? Because we last skipped this and it's greedy. Well, we only have to keep track of the thing. If we skip the 4, then we only have to keep track of two things, right? We only have to skip the current max number. So okay, so I think we're still on the right track, even though we're wrong. I don't know how many people got this yet, but 106 really. I don't think this is easy at all. So I don't know. I mean, maybe I'm just dumb. Okay. So okay, so we need to keep a track of number in which we skipped, right? And we only really have to keep track of the 2 because once it goes out of bounds, it doesn't matter anymore if it's not one of the top 3, right? Okay, fine. So it's not last skip, right? How do I want to write this? We have half an hour. We could probably get it, but okay. Let's think about it. Okay. Okay. So right? Okay, fine. Okay. So there's this, and then now we want to say best skip. We want to skip a number, right? So if previous, well, yeah, okay. So there's only one number. So previous 0 is in best skip. Then we just kind of best skip. We just kind of keep going, right? Okay, if it's not in there, then what? Then we want to skip it. So then how do I want to write it, Larry? Okay. And this is just previous best plus I plus 1, right? So that's just skipping, right? If it's there, then we also do the same, actually. Nope. Right. But what do we do with the other keys? That's fine. Okay, fine. I got it, maybe. Okay, so if it's not in skip, then we do the skip thing. And that's it, really. Right? Because we already skipped it. Okay, fine. There's only one element, so that's not even right. Okay. Otherwise, this part is trickier. Right? So for key in best skip.keys, we want to say, okay, best skip of key. So for the keys that we already care about, if previous of 0 is equal to key, then we get to skip it. So we'll just keep going. So that's going to be I minus previous of 1, right? If it's not, then what happens? If it's not, then yeah, then this is just equal to I minus previous of 0. Okay, but then now we want to write if previous 0 is not in keys, not in best skip, then best skip of previous of 0 is equal to previous best plus I minus previous of 1, and that's it, right? Maybe. This as well, but yeah, this is just max, I think. At least we got those right. But the thing is that this may time out, so that's why. For a lot of numbers, so we have to trim, right? So 230, skipping 4 is, oh yeah, skipping 6 is, nope, this one, okay, yeah, skipping 6 is 230, skipping 4 is 213 and 118, but we want to keep track, right? So then here we want to clean up. So okay, two of values. So we want to keep at least, at most 3, I want to say. Yeah, okay. So the 2 largest, right, okay, fine, yeah. I don't know, that's necessary. Okay, fine. And then now for key and best skip dot keys, and actually we call it key. If best skip dot key is in previous or it's in, if it's one with top 2, well, I just say top 3. I think it's fine to be a little bit whatever. Or key is in previous, then continue. Otherwise, we want to delete it. For key and removal. Okay. 9, 12, 50. I think that's right. I mean, whether that's right enough, we'll see. Yeah, okay, fine. Did I not put anything? Okay, fine. It's YOLO. Hope it doesn't time out. Is it timing out? I mean, it's right. It's just that it times out, right? We're just a little bit lazy on the something. There's only 2. This only does 2 things. Yeah, I don't get it. What is n again? 10 to the 5th. I don't know how this could be any faster. Honestly, it's Leetcode is being dumb. Like, is it the fastest? Probably not, but maybe we could do something like that. This is like stupid again. Because I don't know, like I could do some optimizations, but I don't know that it'll be fast enough. That's why I'm like will it make a difference? It's hard to say, right? So it's kind of silly. All right. I don't know if this is good, but we'll see. It is very silly though. No such element exception. 698. Why don't they give me real thing? Oh, 75. Here. Huh, no such element, huh? I don't know. I want to debug the Python code or the Java code. I hate Leetcode. I can't get anything right. One is equal to 10. This is already wrong, I think. For that's actually really annoying that it is wrong. Like how? Tell me how. I'm just so frustrated because it's. What is previous? What was my code? I don't even know anymore. Previous best. Oh, it's the way. What does this mean? Actually, I don't know why this is there. I don't know if that changes anything. I mean, this is now off by some. I don't know how this is wrong. Like what made it such that the numbers are wrong? I don't know. Is it fast though? It's fast, maybe. Yeah, I mean, I don't think that helps. I mean, this is nice, but I don't know why these numbers are wrong though. One is equal to 10. Am I off by one somewhere? I guess so. Update all the previous keys. I mean, okay, I don't know. I have to keep on. Why is it 9-4? So we skipped a 1. Then at 4 we get +3. No, it's 7, right? We don't skip the 1. If we skip the 1, then this is previous best. That's where the code is wrong. Oh, that's where. But okay, fine. There's another place where I do that, right? Okay, now it is. Nope, still wrong. 9, 10 instead of 12. This is what happens. Leetcode hates me. I mean, this is definitely weird. Before we move on, long threshold is weird, so that may be why. Because we definitely have this thing here. Okay, let's see. Because we want to keep keys small, right? That's why. What happened to my code? My code, I didn't write it like this either, but they kind of optimized this part for me instead of yeah, I don't know, but it reads my intention well incorrectly, so I have to kind of write it in Java. We'll see. Was it entry dot? Okay, so okay. Yes, this is, if this is greater than, I think actually I think I see what it's doing, but still. If it's greater than 2, then going to 2, otherwise, no. Something like that. If it's 0, then we don't do anything, right? Yeah. Actually, if that size is greater than equal to 3, we do it. It don't really matter that much before that. So then we don't even need this. We just need this. We don't have to do math. Oh. Okay, so now this is right. Let's get rid of the print statement. And hopefully this is fast enough and also not wrong. I spent so much time. If it times out, I'll be very sad. I don't know how to make it not time out. I mean, this is pretty much linear. Like, is it the best linear? Maybe not, but it is linear. So why? We have 15 minutes. I converted to Java. Still no good. I don't know how to do this necessarily, but yeah, I mean, does that change anything? I guess that's just too slow, even for one end. So maybe it is just, maybe I should have tested it. Well, now we're doing 7 cases. How do we keep it fast enough? What if we just skip all this junk? Alright. Oh, wait, what? Did I mess something up? Why is that? Oh no, it's because it could be smaller than 2. That's why. I'm just being dumb. Why is it so slow still? Meanwhile, people are cheating, you're getting it right, and I'm just frustrating that I'm doing a linear time optimization thing where maybe 4, I don't know. We're only doing 4 things, it's 4 times n. Why is this so slow? I don't get it. Okay, if we don't do this, is that okay? Yep, it. Oh. What is the time happening? What is the expensive part of this? That's what I don't get. Is it this part? Maybe it is that part. Okay, then I have time to optimize that part, so that's good, I guess. Okay, fine. Fine, I can write. Okay, is that better? Still so slow. Why? What is wrong with this f sub I? What did I have before that was fast enough? If I just skip this or something, or what? Oh well, it's just not appending, I guess that's why, but why? How? I don't get it. I just want 2 big numbers. Is f sub I doing something weird? Why? I don't get it. So this is fast enough if we don't care about sorting. Why is this so much slower? Well, we also only care about okay, fine. So is that okay? Why? Am I just like lucky with some random stuff with the previous or something? I don't get it. Like, why is just appending it good enough? And also, this is not that slow. I don't get it. Leetcode. What do you want me to do? What is going on? What is taking the time? I really don't get it. Why is this just appending K fine? Okay, fine. What did I have again? Like, why? Okay, that's why. Okay, so I'm doing something wrong, that's why. Okay. Oh no, yeah, okay. That's fine, honestly. Okay, so there's something wrong I'm doing here. So best skip.keys. We removing here, right? Oh, we don't remove it here. Okay, fine. I forgot to remove. But why? We have 3 minutes and I'm just debugging something dumb. Right? If it's or key is in previous. Okay, so maybe it is not Leetcode 4. Maybe it's just I'm dumb. But, okay, previous only 2 numbers, so that's why. Why you? Okay, so it's 13, but all these numbers are 13. That's why. Okay, so if the key is not in is previous, then we continue, or okay, we need a best out. Okay. I'm a little bit too slow. I have 2 minutes. Focus, focus, focus. I'm dumb. Okay. 1 minute if key is in previous or I don't know that this is right, but it is a YOLO submit just because. But this is wrong. This is a so poop. Okay, YOLO. That was actually a bad mistake on my part. It may still time out, or wrong answer in this case, because I don't think that I'm keeping track of the right ones, but I was dumb on that one, actually. And the time ran out. Oops, not this one. I spent too much time thinking that was Leetcode's fault. And that some of it is honestly on Leetcode, right? Because some quick submit by accident. I mean, this is just timeout. I just wanted to see whether that fits this one. But some of it is on Leetcode, right? Because I can't know whether it's just me or Leetcode anymore, you know? I think that's the problem. So that's right. So we have to fix. So 4 is not enough. That's what I wanted to say. We want to get the best. That's so guys. So we're skipping. Just sort, Larry. I wasn't thinking clearly, but I mean, this may still time out, frankly, but oh, it should still time out because I didn't fix this part. Okay, so I don't know how to fix that actually. So maybe I'm wrong anyway. I think the idea is kind of right, but it's just that I wasted so much time on thinking that it was Leetcode's fault, because it usually is Leetcode's fault. Which is why like it's a little bit disheartening to figure out, right? I thought you could maybe skip something like that, but Okay, so let's say we skip a number, right? So we only skip one number. Can we get the suffix from this? So maybe this is wrong anyway, to be honest. Like, I thought maybe there's some pigeonhole thing that I can figure out, but then I kind of messed it up. But I did waste like 15 minutes because I thought it was Leetcode's fault, which I was wrong about for once. But like, even just getting this is not enough, then I don't know. Because here, probably just skipping the 5th one or something, I don't know. I mean, that's fine. I don't get it, though. Why? Does it time out? Shouldn't time out though, I don't think. At least not. I mean, this was my test case anyway that I was generating manually with my thing with these. Like, as long as, okay, so that's good in that that's what I think. Not first. Oh, I did it the wrong way. So no, this is right. If not first, oh no, if first we continue. Okay, so I actually just did this wrong. Whoops, that's bad logic. Okay, but then now this is wrong, right? So you can't skip it. Why does that differ? Like, why is this the one that we keep track of a lot of funky things? We don't need this case. We need the other case. Oh. We don't even use this. So it must be something with this previous. That doesn't even fix it. Oh, because this thing means that it's not going to be. Oh no. Is my idea wrong? I mean, maybe. Well, the idea is right, but it's an n squared dp, which if you write it that way, I could win it in a much cleaner way. I don't know if this works. I don't think this is right, but maybe it's at least closer. Oh well. I don't know why that is. Like if this is 1, it doesn't work, right? Does it? Maybe I was wrong. Huh. I just didn't write it correctly. Because it was taking a suboptimal one, I guess. I should have gotten it, I guess. Ooh, first is not right. Then why is count right? Oh, because I messed up. I meant this. But then, no, this is still right. What did I mess first up? See, well, we continue to skip, right? Submit. But why is the first version wrong? Did I mess this up? Maybe I messed up. I don't remember how it worked. If first, then we get to skip. First is equal to first, right? Maybe I just had it wrong. Maybe my first code was wrong. Huh. That's interesting. That's very sad, actually. I mean, I guess I could have gotten it. What was it? I'm looking at my old code. If true, then we set first is equal to false. Why is this wrong? Huh? It looks about the same for me. Right? I hate this UI. Oops. Why is this right? I could done. Oh, maybe I looked at the wrong code. Whoops. I wanted the wrong answer one. What was I? I hate the new UI. It's so stupid. Key and oh no, that one's. I knew that one was wrong. Time limited. This one was because I just had this one. The if statement was wrong. And also the V part is a little bit sketch. I think, maybe. If first. No, yeah, this if statement was wrong. Why did I even have that? I think maybe this idea is right. I don't know. I forget. Let's try again, because we already have it now. Okay, so why was this wrong? I guess I could just. This is supposed to be wrong, right? Because of, yeah. I mean, or this is right, but because of the assertion error, so it would be wrong. If and I yeah, this is just weird. Just true. And then now if this is true, then we skip it, right? And first is equal to 4. So I have that one wrong. But then this one, does it give the right answer? It might not, because it gets to whatever. But I guess I just needed to do this. Maybe. I guess I could run the case I was wrong for first. Yeah, which is the same case. And the reason is because, what is the reason? I mean, the reason is because the first one that we see is not always the last one, but maybe I could have done something like that. Maybe that would have fixed it. I mean, I don't know. I think some. I mean, honestly, I would have gotten it, but Yeah, I mean, I think with this one, I kind of blame Leetcode just because, I mean, that's the thing about having a bad platform, right? Is that when you have a bad platform, even like when I get a time limit exceeded, I don't know if it's me or Leetcode anymore, right? Like, and it just makes it very, yeah. So people are trolling me on Discord, but yeah, I mean, because basically, because when I get a time limit exceeded, I just don't have confidence that it's me or Leetcode or either of those things. Where in every other platform, you'll be like, oh, no, I trust the platform. I know it's me. Let me try to figure out why I'm time limit exceeded. Instead, I'm spending 20 minutes trying to figure out if I could get it to work in Java. And probably the Java code does the same thing. I mean, I wouldn't doubt it because I have the same logic. I have to like change logic just a little bit to fix that. So I don't know. It is what it is. Yeah, I mean, don't give shit. Listen, debate. This is not a debate. No patient. But yeah. Yeah, I mean, I don't know what else to say about this one. It's just, I mean, the problem itself is fine. I feel like a lot of the things is just because of Leetcode being Leetcode. Like I was pretty sure my algo was fine, yeah, I mean that's the saddest part is that I mean, and I knew, and I figured, like I mean, all the things that I implemented here was variation on the same thing, right? So I kind of knew what I did, but I just didn't know that that was having an issue because I wasn't thinking too hardly about it, and because when you get a time limit exceeded in Leetcode, it's not confident that it is my fault or Leetcode's fault. So thanks for watching, everybody. Hit the like button, hit the subscribe button, join my Discord. Let me know what you think about this contest, these problems, explanation, everything in between. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.